QR decomposition means writing a real matrix A as Q times R. Q has orthonormal columns, and R is upper triangular. Simple statement. Suspiciously useful consequences. We will focus on real matrices with linearly independent columns. The complex version just adds conjugates, because complex numbers demand tribute. Start by thinking of A as a list of column vectors, A1 through AN. A matrix is just a vector list wearing brackets. Gram-Schmidt turns those columns into orthonormal vectors Q1 through Qn. Put those Qs into a matrix, and that matrix is Q. The key point is span preservation. The column K only needs the first K orthonormal columns, so the coefficients below the diagonal are 0. Collect those coefficients into R, because later columns may use earlier Qs, but earlier columns never use later Qs. R is upper triangular. Matrix bookkeeping, somehow promoted into a decomposition. Here is the matrix. Its columns are the vectors we will feed into Gram-Schmidt. The output will be Q1, Q2, and Q3. The coefficients that express each original column using the Qs will become R. The first Gram-Schmidt vector is just the first column. Normalize it, and that gives Q1. Then we already know two entries in the first row of R. The dot products of Q1 with the remaining columns. For the second column, subtract its shadow on Q1. Then normalize what remains. This is Gram-Schmidt refusing to let old directions contaminate new ones. The remaining entry in row 2 of R comes from dotting Q2 with the third original column. For the third column, subtract the shadow on Q1 and the shadow on Q2. Normalize the leftover vector, and Q3 appears. Against all odds, the bookkeeping worked. Put the Q vectors into Q, and put the coefficients into R. The zeros below the diagonal are the whole point of the triangular shape. As a quick check, Q transpose Q is the identity. A equals QR, and multiplying by Q transpose gives R. The algebra has receipts. So QR decomposition is not a mysterious matrix trick. It is Gram-Schmidt applied to columns, with every coefficient carefully filed into R. Bureaucracy, but useful. Next time, QR immediately pays rent. Linear least squares, where AX equals B is impossible. So we ask for the least embarrassing approximation.